Hello students, welcome to this lecture one arithmetic progression. Okay? So in this lecture we will discuss any term of an AP and then we'll see some examples on this topic. Okay. So let's get started. So let us consider the situation. Rina applied for a job and got selected. He has been offered the job with a starting monthly salary of 1000 rupees with an annual increment of 500 rupees. What would be her monthly salary for the fifth year? Okay. So in this example, here we consider this situation. Rina applied for a job and he got selected. He has been offered the job with a starting salary of 8000 rupees with an annual increment of 500 rupees. Okay. So what would be her monthly salary for the year? So to answer this examples, let us first see what are let us see what are monthly salary for the second year. Okay, so here we first will see what what her monthly salary for the second year. Okay, so it would be 8000 plus 500. This is equal to 8500. Okay, so in her second year, in the second year, our salary would be is 8000 plus 500, that is equal to 8100. In the same way, we can find the monthly salary for the third, fourth and fifth year by adding 500 to the salary of the previous year. Okay, so the salary for the third year, that is actually 8500 plus 500. Okay, so we can write 8500 as 8000 plus 500. Okay, so we can write this as is equal to 8000 plus 500 plus 500. Okay, so here the in so the salary for the third year that is equal to 8000 plus 500 plus 500. Okay, now we can manipulate it as equal to rupees 8000 plus 2 times 500. Okay, so this is equal to rupees 8000 plus 3 minus 1 times 500. For the third year, our salary would be 8000 plus 3 minus 1 times 500, that is equal to 9000 rupees. Okay, so here you observe some pattern. Okay, so here basically you observe this pattern. We add 500 its successive terms, then we'll get to its preceding terms, then we'll get the successive terms. Okay, and here we also observe that if we take this first term, first salary of our job, okay, 8000 plus number of year minus 1 times annual increment 500. Okay, so here we can write it as 8000 plus 3 minus 1 times 500, that is equal to 9000. Okay, now let us see salary for the fourth year. So salary for the fourth year, that is basically salary for the third year plus 500, since annual increment equal to 500 rupees. Okay, so salary for the fourth year, this is equal to rupees 9000 plus 500, and this is equal to 8000 plus 500 plus 500 plus 500, that is actually equal to 8000 plus 3 times 500. Okay, and this is equal to rupees 8000 plus 4 minus 1 times 500. So for the fourth year, our salary would be 9500. Okay, and we can write this number 9500 as 8000 plus 4 minus 1 times 500. Okay, that is actually give to us first salary plus number of year minus 1 times annual increment. Okay, so salary for the fifth year, that is actually equal to 9,500 plus 500. Okay, and 9,500 can be written as 8,000 plus 500 plus 500 plus 500, and here we have 5 plus 500. Okay, so here basically you get 4 500. Okay, you added 4 500, and this is equal to 8,000 plus 4 times 500. Okay, so this is equal to 8,000 plus 4 times 500, and 4 can be written as 5 minus 1. Okay, so this is equal to rupees 8,000 plus 5 minus 1 times 500. So for the fifth year, the salary would be 10,000. Okay, so the salary for the fifth year is equal to 10,000. And in this example, basically we have asked what is the expected salary for the fifth year. Okay, what is the salary for the fifth year? So the salary for the fifth year would be 10,000 rupees. Okay, so here observe that we are getting a list of numbers: 8,000, 8,500, 9,000, 9,500, and 10,000, and dot dot dot. Okay, so you get the numbers. So here these numbers are in AP. So now question, these numbers are in AP or not? Okay, so now looking at the pattern from above, can you find her monthly salary for the sixth year? Okay, so the fifth and the 15th year, and assuming that she will still be working in the job, what about the monthly salary for the 25th year? Okay, you would calculate this by adding 500 each time the salary of the previous year to give the answer. But this process is very lengthy process. Okay, process is very lengthy process. So here we have to find a formula that will help you to find find the find a monthly salary for the sixth year, for the 15th year, for the 25th year. Okay, so here we'll basically looking at the pattern. Okay, looking at the pattern. So can we make this process shorter? Now question, can we make process shorter? Okay, when we this would calculate by adding 500 each time to the salary of the previous year. Okay, but this process is very lengthy process. So now question, can we make this process shorter? Okay, so let us see. You may have already got some idea from the way we have obtained the salaries above. Okay, so there we have calculated step by step for the salary second year, for the salary of third year, for the salary of fourth year, for the salary of fifth year. Okay, so there we already got some idea. Okay, so we use this idea and we'll make an pattern, okay, and we make a general formula for finding the innate term of an AP. Okay, so salary for the 15th year, that is basically equal to salary for the 14th year, that is plus rupees 500. Okay, and salary for the 14th year, that is equal to rupees 8,000 plus 500, add 500 13 times plus 500. Okay, and this is equal to rupees 8,000 plus 14 times 500. Okay, and this is equal to rupees 8,000 plus 15 minus 1 times 500. Okay, and that is equal to basically rupees 15,000. Okay, so first salary, here we get this general form: first salary plus number of year minus 1, that is 15. Here 15, number of year is 15 year. Okay, so 15 minus 1 times annual increment. Okay, so in the same way, her monthly salary for the 25th year would be 8,000 plus 25 minus 1 times 500. That is basically equal to 20,000 rupees. Okay. So here we get this pattern. First salary plus 25 minus 1 times annual increment. Okay. So this example would have given you some idea about how to write the 15th term or the 25th term and more generally the innate term of the AP. Okay, so in by this example basically we get some idea for finding the innate term of an AP. Okay, so in this lecture our main motive is find the innate term of an AP. Okay, so in this lecture we'll explore so many examples. By that examples will clear this topic. Okay, so here let a1 a2 a3 dot 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 be an AP whose first term a1 is a and the common difference is b. Then the second term a2, this is equal to a plus d. Okay, and this can be written as a plus 2 minus 1 times d. Okay, and the third term, this is actually a3, that is equal to the second term plus common difference d. Okay, that is a2 plus d. So a2 can be written as a plus d. Since a2 is a plus d, okay, so we can write it as a plus d plus d. Okay, and this is equal to a plus 2d, and this can be written as a plus 3 minus 1 times d. Okay, so the third term of this AP is equal to a plus 3 minus 1 times d. Okay, and the fourth term a4, that is equal to a3 plus d. Okay, so the a4 is basically we obtain by adding d with the third term. Okay, so a4 this is equal to a3 plus d, and we know a3 that is equal to a plus 2d. Okay, so we can be written as a plus 2d plus d, that is equal to a plus 3d. Okay, and this is equal to a plus 4 minus 1 times d. Okay, so the fourth term of this AP, this is equal to a plus 4 minus 1 times d. Now, looking at the pattern, so we can say that the innate term of this AP, AN, this is equal to the first term A plus number of terms N minus 1 times common difference D. Okay, so the innate term AN of the AP with first term A and the common difference D is given by AN. This is equal to A plus n minus 1 times common difference d. Okay, so here an is also called the general form of the AP. If there are m terms in the AP, then am represent the last term, which is sometimes was denoted by L. Okay, so if we have a finite AP, that means if we have a arithmetic progressions which having finitely many terms. Okay, that case, if there are m terms in the AP, then a subscript m, this represents the last term of this AP, which is also denoted by L. Okay, so let us consider some examples. So now in this section we will explore some examples on this topic. Okay, so in this example we have to find the tenth term of the AP that is given to us 2, 7, 12, dot dot dot. Okay, so here we have to find tenth term. Okay, so here we have given this list of numbers that is actually an AP. Okay, so we have studied in our previous lecture, if we have an AP, then we can find the first term of that AP, and also we can find the common difference D. Okay, so in this AP, the first term A is equal to 2, and the common difference D, this is equal to second term minus first term, that is 7 minus 2, this is equal to 5. Okay, and here we need to find the 10th term of this AP. Okay, so here basically we have n is equal to 10. So we have this formula for finding nth term of an AP, that is an is equal to a plus n minus 1 times d. Okay, so n, this is equal to a plus n minus 1 times d. So a10. So now we can put the value of n, this is equal to 10, and the value of a is equal to 2, and the value of d is equal to 5. Okay, so if we put these values, then we get the term a10, that is equal to first term plus number of term 10 minus 1 times common difference d. Okay, so now if we put these values, then we get a10, this is equal to a2 plus 10 minus 1 times 5, that is equal to 2 plus, that is equal to 2 plus 45. Okay, and if we add this, then we'll get this is equal to 47. Okay, so therefore the 10th term of this given AP is 47. Okay, so the 10th term of the given AP is 47. So basically here we use this formula an, this is equal to a plus n minus 1 times d. Okay, now let us see next example. So in this example, we have given the arithmetic progression. This is 21, 18, 15, dot dot dot. Okay, so we have given this arithmetic progression. So which term of this arithmetic progression is minus 81? Okay, so here we need to find the value of n for which the term of the term of this AP is minus 81. Okay, so this is our first question. Then our second question is also is any term 0? Second question is also is any term which is actually 0. Okay, so if there is any term which is 0, then give reason for our answer. Okay, so let us solve this example. So in this example here, we have given the first term a is equal to 21. Okay, and the common difference d, this is basically equal to second term minus first term. Okay, that is 18 minus 21, that is equal to minus 3. Okay, and here we let the nth term be minus 81. Okay, so the minus 81 basically be nth term, and we have to find the value of n. So as we know an, this is equal to first term a plus number of terms n minus 1 times common difference d. Okay, so we have here the values of a, d, and an, and here we need to find the value of n. Okay, so we have this minus 81, this is equal to 21 plus n minus 1 times minus 3. Okay, and it implies minus 81, this is equal to 24 minus 3n, and it implies minus 105, this is equal to minus 3n. Okay, so minus 105, this is equal to minus 3n. Now if we simplify this, then we get the value of n, that is basically equal to 35. Okay, so the value of n, this is equal to 35. So therefore the 35th term of the given AP is minus 81. So this is our first answer of the first question. Okay, so our next question is any term which is actually 0. So next we want to know if there is any n for which an is equal to 0. Okay, so if such an n is there, then 21, this is equal to this is 21 plus n minus 1 times minus 3, this is equal to 0. Okay, so here we get this equation. Now we can simplify this equation. Okay, so if we simplify this equation, then we get 3 times n minus 1, this is equal to 21. Okay, that is n is equal to 8. So the 8th term is 0. Okay, so the 8th term is 0. Now let us move to example number 5. So here we have to determine the AP whose third term is 5 and 7th term is 9. Okay, so here basically we have given two terms, third term and 7th term. Okay, and basically here we have to determine the arithmetic progression. So let us see how to solve this example. Okay, so here we have given third term. So that is A3, this is equal to, we know first term A plus number of terms, here 3. Okay, so 3 minus 1 times common difference D. Okay, and this is equal to A plus 2D. And we have given the third term is 5. So A3, this is equal to 5. So we get this equation A plus 2D. We get this equation A plus 2D. A plus 2D, this is equal to 5. Okay, and naming this equation number 1. And we also have given to us the 7th term of this AB. Okay, so A7, we know A7, this is equal to first term A plus 7 minus 1 times D. That is equal to A plus 6D. And this is equal to 9. That is given to us. Okay, so we get this equation. So this equation naming equation number 2. Okay, so now we get two linear equations, that is we get a pair of linear equations. And we have studied in our previous chapter how to solve a pair of linear equations by using algebraic methods. There we have studied two main methods, that is elimination method and substitution method. Okay, so here we can easily use that two methods, and two methods among one of them if we use one methods, like if we use elimination method or substitution method. Okay, so here we get the value of A is equal to 3 and the value of D is equal to 1. Okay, hence the required AP is 3, 4, 5, 7, 6, 7, dot dot dot. Okay, so this is the AP whose first term A is equal to 3 and the common difference D is equal to 1. Okay, now let us move to next example. So in this example, we have to check whether 301 is a term of the list of numbers 5, 11, 17, 23, dot dot dot. Okay, so in this example, here we have given 301, and here basically we need to find check whether this is a term of this list of numbers or not. Okay, so let us check it. So here A2 minus A1, this is equal to 11 minus 5, that is equal to 6. Okay, and A3 minus A2 is equal to 17 minus 11, that is equal to also 6. Okay, and A4 minus A3 is equal to 23 minus 17, that is equal to 6. As AK plus 1 minus AK is the same for K is equal to 1, 2, 3, etc. Okay, so AK plus 1 minus AK, where AK plus 1 is the K plus 1th term and the AK is the K term. Okay, so and the difference AK plus 1 minus AK is the same for K is equal to 1, 2, 3, dot dot dot. Okay, so the given list of number is an AP. Okay, now here the first term A, this is equal to 5 and the common difference D is equal to 6. Okay, now let here 301 be a term the nth term of the AP. Okay, so here we let 301. This is actually nth term of the AP, and we know that nth term of an AP, an, this is equal to a plus n minus 1 times common difference d. So here an is 301. So 301, this is equal to first term is 5 plus n minus 1 times common difference d is equal to 6. Okay, that is 301. This is equal to 6n, is equal to 6n minus 1, and so n is equal to 302 by 6, and that is equal to 151 divided by 3, and this is a fraction. This is a fraction, and here we know the term of an arithmetic progression always a natural number. Okay, but n should be a positive integers. Positive integers. N should be a positive integer. 0, 1, 2, 3, 4, 5, dot dot dot. Okay, and so here 301 is not a term of the given list of numbers. Okay, so 301, this is not a term of the given list of numbers. I stop here this lecture. Thank you very much to all of you.